Okie dokie. Okay, let's go ahead get started. So today, of course, we're just reviewing. So looking at the questions that you guys have posted in Discord, and we're going over them. So first one we have from Molly talks about specific heat. We're given 5 different metals there with their heat capacities. And it looks like we're giving the same amount of heat to 50 gram samples, and we're seeing which one's going to reach the highest temperature. So with this one, we can see here that the only difference is going to be the specific heat capacity, right? So, as kind of a test-taking strategy, if you can identify that the only difference is going to be the specific heat capacity, what you should do is test both of the extremes. So either a high specific heat capacity will lead to a high temperature, or a low one will. There's really no way it could be any of the 3 middle ones. So let's go ahead and check what happens if we apply a certain amount of heat to aluminum as well as to gold. So let's try those out. So if we try aluminum, we know that Q equals MC delta T. Let's just go ahead and say that we're going to add, how about 1,000 joules? Why not? Let's just decide that. We'll just use the same one for each one. So it's going to be 50 times 0.903 times delta T. Therefore, delta T will equal to, once we solve this with our friend Google, 1,000 divided by 50 divided by 0.903, we get 22.15, let's say. And now let's try the same thing with gold. 50 times, what is gold's 0.128? So let's go ahead and try that out. If we do that one instead, we get 156.25. So very clearly there we can see that gold is going to be the higher one. Without having to deal with fake numbers, we could have solved this thing for delta T. And seen that since specific heat capacity is in the denominator, that means that if specific heat capacity goes up, then delta T will go down. They're going to be inversely proportional here. So for the same amount of energy and mass. So we can see that that would be the case. So therefore we're looking for the one with the lowest heat capacity, which is going to be gold there. All right, so hopefully that answers that one. But it's always a good idea if you have the time to just plug in fake numbers that fit the criteria, and you can just mathematically see what happens. Alrighty, so let's go ahead and apparently use dark blue to answer Molly's second question. So jet fuel has a mass of 97.5 kilograms. Density is 0.804 grams per cubic centimeter. And we're asked what's the volume. So we can set this up as using our formula, or we can use unit conversions. I think I'm going to do the unit conversion way. Notice we have kilograms here, but grams here. So we need to make sure our units are going to work out. So while we do our unit conversion, we're going to have to get rid of this kilograms and turn it into grams first. I think that's probably what went wrong with this problem. Alright, so that's how we would do that. And now we're going to worry about using our density. We're going to put the grams component on the bottom so that it cancels out. We're going to see that kilograms will cancel, grams will cancel, be left with cubic centimeters. And so the answer apparently is going to be 1.21 times 10 to the fifth cubic centimeters. So I think that was the confusing part there, is just watch for units. Since we're giving kilograms, we need to convert that to grams first before we can use our density. So if you wanted to use it in the density formula, you have to make sure that it's in grams first as well. Okay. So we've got Cassie's next. Of course, if any questions on these come up, I'm happy to answer them. So, okay. We're looking for how many kilojoules we're taking a 150 gram sample of silver from 25 to 135, and then the heat capacity is 0.235 joules per gram degree Celsius. Okay. So pretty straightforward here. We have a M, we have a C, and we have a delta T. We're solving for Q because it's asking for kilojoules. That's energy, right? So let's go ahead and see what we can do here. So M, 150 grams. C is 0.235. And then our delta T is going to be 135 minus 25 degrees Celsius. Put that in there. So if we do this, let's see. 150 times 0.235 times 110. You get 3877.5 joules. How do we know it's joules? Well, we just cancel out all the units like before. We're left with joules. However, the question does ask for kilojoules. So we're going to want to convert that appropriately. We know that 10 to the third joules will be 1 kilojoule. And so we're looking at, oh, by the way, it looks like we're going to have 3 sig figs for this. So 3.88 kilojoules would be my answer there. 3 sig figs, so don't forget, you might see that 25. But remember, that's when you do the math, you follow subtraction rules, which tells you the ones place is significant. So this number actually has 3 sig figs here. And so overall, you'll have 3 sig figs in your answer. Just in case that was a question there, because I didn't see what Cassie actually put as the answer. Okay, so you get 3.88. Cool. Alrighty. If we look at the next one, this is from Ted. And apparently we're again using dark blue. Why not? Okay, we have 4.123 times 0.12 plus 24.2. All right, so first things first, we got to do the parentheses component. Let's go ahead and do that math real quick. 4.123 times 0.12. Doing that, we get 0.49476. Remember, when we are dealing with multiple types of operations here, we're going to want to not round right away, but we'll want to go ahead and indicate how many sig figs that number should have. So this number should have 2 sig figs, which means that it's significant to that 9 there. The other 3 numbers are not significant. So let's go ahead and do our addition. 24.2 plus 0.49476. If we do that, notice, remember when we're doing adding, we have to look at where the significance is. So we're comparing these two. Remember, the 9 is where that number is significant, the second number. We always go with the least significant digits. So that means we're going to be significant to the 10th place, which means we're going to keep these 3, and we're going to round according to this number here, which means that we should round this to 24.7 accordingly. Let's go ahead and see, is that the answer? Yes. Okay, good. All right, the last one we have here, 1 mole of oxygen gas. Apparently we're going to do TED 2 in green. We're really just asking what's the molar mass of oxygen gas. I see you've put 16. Don't forget, oxygen gas is O2, right? We have 7 diatomic elements. Our Hofbrinkels. Anytime we talk about those guys, they're diatomic. Yep, that's the thing. And so because it's O2, that means you have 2 times oxygen, which is 2 times 16, which is 32. Yep, so your answer is different. Different for what? Okay. This is a multiplication dot, by the way, not a decimal. But yeah. So I guess that's kind of a trick question. Maybe. But yeah, this was the part that the question was going off of. Okay, cool. Let's see, what do we have next? Looks like that's it. So, okay, well, I guess that's it then for today. Unless anybody has any other ones that they want to post real quick or something. Other than that, looks like we've done them all. So, if there's nothing else, then we're done. And I will see you guys on Tuesday, if that's the case. Are any of you planning on putting forth any more questions? Just okay, we're good. All right, yeah, I didn't expect this one to take super long today, so it's just kind of addressing things. So cool. So I would definitely recommend also, if you got anything else incorrect, double check it, see if you can figure out what went wrong there. And of course, you can always just throw it in Discord, like, hey, why is this one wrong? Blah blah blah. We can always go over that in writing. So cool. Alrighty, I guess I'll throw this up on Discord for people who wanted to see it. But yeah, otherwise, I'll see you guys on Tuesday. Enjoy your long weekend. There's some homeworks up. There's a bunch of lab sims that are going to be 3 lab sims that are due in 2 weeks, so maybe start working on those since there's only 1 worksheet that's coming up due. So take a look at those. Those should be coming up on Canvas as like upcoming assignments. So, alrighty. See you guys Tuesday. Enjoy your weekends.